we'll go to the next level questions here. Now we'll discuss the next topic here, that is GOC, in which we'll be discussing about reaction intermediates and the stability order of that reaction intermediates and the stabilizing factors which will stabilize this reaction intermediates. Now let us discuss some advanced level bits related to this topic, that is GOC. So in this first we'll discuss about the first type, that is section 1, which includes single answer questions. So in that single answer questions, now let us discuss the first question, and the question is in this way. Now the question is like this: the correct stability order of the following resonance structures is. So in this question 4 options are given and you have to find out the stability order of this resonance structures. So the 4 options are like this here. So first compound is given in this way, a second compound is given here like this, a third compound is given like this here, and the fourth compound is given. So which is having more stable structure, which will be the more stable resonance structure? So that is the question given. So before identifying which will be the more stable resonance structure, let us see the rules for these resonance structures. So what are the rules is here? The rules states like this. So for finding out here most stable resonance structure, we have to follow the rules. So what are the rules is here? The first rule states that all the atoms in the resonance structure should have 8 electrons, that is octet number of electrons it should have here. And the second rule states that here more electronegative atom should have negative charge but it should not have positive charge, and more electropositive atom should have positive charge but it should not have negative charge. And the other rule, it states that suppose positive and negative charge both are present in the same structure here, then positive negative charges or negative positive charges, they should be nearer because there will be opposite charge and attractions will be there, but negative charges or positive charges, like charges, they should be far away because like charges will have repulsion, so that molecule will become less stable here, so they should be far away. So these are the rules what you have to follow for identifying the stable resonance structure. Now based on these rules, now predict what will be the order of resonance stable structures in this question here. So these are the 4 options, 4 compounds given here. In this, if you see the first option here, first compound, so in this all the atoms in this molecule are having 8 electrons. So it is having 8 electrons and positive negative charge are nearer here. So as it is having 8 electrons and it is the most stable form, you can take here. So 1 is most stable form, you can take here because it is satisfying all the rules here. So we can take 1 as the most stable form. Now going to the second compound here. In the second compound, if you say here this carbon is having only 6 electrons. So that means it is not satisfying the first rule. So we can take it as a least stable compound. Now if you take the second one, third compound here, in this compound all the atoms are having octet configuration. So they are all having octet configuration, 8 electrons it is having here. And in this compound if you take here, so here also carbon is having 8 electrons. This nitrogen is also having 8 electrons, 1, 2, 3, 4, 5, 6, a lone pair of electrons will be there here. So this is also having 8 electrons here, but this nitrogen it is having 1, 2, 3, 4 and 5, 6. It is having only 6 electrons. So that means it is not satisfying the octet configuration. So that means we can say this as the least stable because it is not satisfying the octet configuration. At the same time, nitrogen is carrying positive charge because more electronegative should not carry the positive charge. That means we can take the fourth compound as the least stable compound. And in these 2 compounds, second one and third one, which will be the stable one means you can predict here. Second is having nitrogen with negative and it is not having octet configuration, and in this it is having octet configuration. So we can take a third is more stable. So finally what we can give the order is here, 1 is more stable than third compound because in that all the atoms are satisfying the octet configuration, and third is more stable than 2 because in this one of the atom is not satisfying the octet configuration, and this also nitrogen is not satisfying the octet configuration. So we can take the fourth compound as the last compound in this stability order. So out of this 4, only the first 2 compounds are satisfying octet configuration. So we can take first 2 compounds as stable compounds. Among these 2, this is most stable because this is nitrogen is carrying positive charge, and these 2 are not containing octet configuration. So these 2 we can take them as least stable, and among these 2 this will be the least stable because nitrogen is carrying here positive charge. So in that way we can take this as the order of stability of this resonance structure. So finally the answer for this question is, so we can select this order. So this order is represented in the option B. So correct answer for this question is option B. Now next question, question number 2, and here is the question. Arrange the following in increasing order of the heat of hydrogenation. So here the heat of hydrogenation is asked here, and what is the relation here, how to find out the heat of hydrogenation means we can give for these alkenes you have to go to find out here heat of hydrogenation. So we can say here heat of hydrogenation of the alkenes. So this is inversely proportional to stability. Inversely proportional to stability, and the stability of this alkenes we will be deciding by taking into the consideration of the phenomena hyperconjugation. So which depends upon number of alpha hydrogens. Number of alpha hydrogens. So more the number of alpha hydrogens, more is the stability. More the stability, less will be the heat of hydrogenation. So it is asked here in increasing order of heat of hydrogenation. So more heat of hydrogenation means it will be the least stable one. So if you consider here the one which is most stable will have a less heat of hydrogenation, and the one which is more stable will have more stable, it will have a less heat of hydrogenation. So let us consider like that here. Stability order is again directly proportional to number of alpha hydrogens. Now in this if you compare here, so the first one which is here, first compound alkene, this is a C double bonded group here. C double bonded group attached carbons will call sp3 hybridized carbons. These carbons hydrogens will call them as alpha hydrogens. As such, this carbon is having 3 alpha hydrogens, this carbon is having 3 alpha hydrogens, and this carbon is having 2 alpha hydrogens here, and this carbon is having 2 alpha hydrogens. So in that way here this compound is having 3 plus 3 6 and 2 8, and total 10 alpha hydrogens were there in this compound. So as a result we can take this alkene as the most stable one here because it is having more number of alpha hydrogens. Now coming to the next one, and next one if you take R here, R is having here CH2 group, here no alpha hydrogens, here CH, and it is having only 3 alpha hydrogens. So R is having very less alpha hydrogens, so that's why it will be the least stable one, and S is having here alpha hydrogens 1 2 3 4 alpha hydrogens it is having here, and Q if you take here it is having 1 2, and this carbon attached here this is 3 alpha hydrogens it is having here, so 5 alpha hydrogens it is having. So here 5 alpha hydrogens, here 4 alpha hydrogens, and this compound it is having only this carbon attached, so 2 alpha hydrogens and 3 alpha hydrogens were there. So R is least stable, and hence the heat of hydrogenation will be in this order. So stability order will be like this here. Stability order will be in this way here. So P is more stable than the next one Q. Q is more stable than here S, and S is more stable than R. So stability order is like this here. If the stability order is like this, then heat of hydrogenation order will be in the reverse way. That is, so it is more for R here, R greater than S greater than Q greater than P. So the correct answer for this question is option C. Now we will go to the next question, question number 3, and the question is like this. The correct order of basicity of the following compounds is, and in this question now 5 options, 5 compounds are given, and the 5 compounds are amine compounds, amine nitrogen based compounds here, and that 5 compounds are like this. So it is given as first compound is given like this here, and the second compound is given as NH2, a primary amine, and the third compound is also an amine, but it is a secondary amine given here, R2NH2 secondary amine, and the third compound is given, and fourth compound it is an amide compound is given, and the fifth compound it is given a cyano compound. Cyanide compound is given here. Now let us discuss the basicity order of these compounds. So in this case, if you observe here, nitrogen carrying lone pair of electrons will show basic nature. The basic nature of these compounds, nitrogen containing compounds, is due to the presence of lone pair of electrons on the nitrogen, and they will show here Lewis basic character, and lone pair of electrons are present here. Now if you observe in these compounds here, in all these compounds we can observe nitrogen containing lone pair of electrons, and if you observe in the first compound we can see 2 lone pair of electrons. So as a result we can take first compound as more basic. It is more basic. Now let us take the second, third, fourth and fifth compounds. So if you observe in this case here, in these two are amines and this is an amide and that is a cyanide. So in these compounds here, we know very well that amines are more basic, because here the nitrogen is sp3 hybridized. sp3 hybridized nitrogen will have the lone pair of electrons spreaded easily and they can donate the electron density easily. So they are more basic, and in these two secondary amine is more basic because of the presence of CH3, which is a plus I affecting group. So as a result we can take 3 is more basic than 2. And coming to these compounds here, fourth one and fifth one. So if you observe in these two compounds, amide compound and cyanide, in case of amide here, lone pair of electrons are present on sp3 hybridized nitrogen, and this sp3, even though it is present on sp3 hybridized nitrogen, they are in resonance with the lone pair of electrons present on oxygen. Oxygen being more electronegative, it can pull the electron density towards itself, and as it is in conjugation with the lone pair of electrons on nitrogen, the nitrogen can be resonated, nitrogen electron pair can be resonated. And if you observe in case of cyanide, the lone pair of electrons are present on sp hybridized nitrogen. When it is sp hybridized nitrogen, the lone pair of electrons are held tightly by the nucleus of nitrogen, so its basic nature decreases. So in that way what we can take is 4 is more basic than 5. So finally what order we can give is here, 1 is more, first compound 1 is more basic than 3, than 2, than 4, than 5. So this is the correct basic order of these compounds showing Lewis basic nature. Now let us select this order, where it is represented in which option. So it is represented in the option B. Now we will go to the second level question, that is section 2. So this section 2 is containing MCQs questions, that is multiple correct answer questions. So each question will have more than one option correct here. So one or more than one option correct will be there here for this questions. So let us go on to this MCQ type of questioning here. So in the first question, and the first question is like this here. So the question is given in this way: dipole moment of which of the following compound is not 0? So it is given it is not 0 here, and the 4 options are given in this way. So first option is given in this way, a 7-membered ring, and the second option is given in this way, a 7-membered ring and a 5-membered ring combined here, and C, a benzene compound is given, and D option, naphthalene is given. So in these 4 options you have to pick the compound in which the dipole moment is non-zero or it is not 0. So when the dipole moment will not be 0 means the condition for the dipole moment to be 0 means if it is a non-polar molecule and if it is having planarity, if the molecule is planar, when the molecule is planar and when the molecule is non-polar, if it is not having any polarity, then definitely the molecule will have a dipole moment, net dipole moment equal to 0. So its dipole moment value will become 0. That is, the condition is when the molecule is planar and when the molecule is non-polar, its dipole moment value will be 0. Now in these compounds, let us find out which molecules are planar and which molecules are polar and non-polar. Now if you take the first option here, so it's a 7-membered ring here, compound here, but this compound, to get the aromatic nature, it will show some polarity. The bond will be showing here polarity here. Oxygen being more electronegative, and it will try to pull away the bonded pair of electrons towards itself. So when it's trying to pull away the bonded pair of electrons towards itself, as a result it will get a structure in which the compound will get here, the carbon will get positive charge and the oxygen will get here negative charge. So double bond's position will be as it is. So in that way this molecule is getting, oxygen is getting a negative charge and the carbon is getting positive charge. So it is acquiring planarity and polarity. So the molecule is planar and with sp2 hybridization all the carbons, and it is having here polarity. So as it is having polarity, its dipole moment value is not equal to 0. So hence we can select the first option in which the dipole moment value is not 0. Now as it is multiple correct answer questions, let us see the second option also. So the second option is given like this here, again a 7-membered ring here with a 5-membered ring. So this molecule is also here aromatic here, and its aromatic nature will also be existing when it is showing here. Conjugate system will be showing polarizing. So because of this polarizing effect here, this molecule will convert into like this here, the compound group will convert into like this. So where we can see polarization, so getting negative charge on this carbon and acquiring positive charge on this carbon, and remaining as it is bonds will be there here. So if you observe in this compound here again, so 1, 2, 3, 4 pi bonds were there. So 4 pi bonds means here, so 4 means 4 pi bonds means it is having 8 pi electrons, and in addition to these 2 negative charge electrons also we can consider. So total it is having 10 pi electrons. So because of the 10 pi electrons it is following the Huckel's rule. So hence it is aromatic in nature. This is aromatic in nature, so it is not losing its aromaticity because of conjugate system, because of polarization, and as it is acquiring polarity, positive negative charges here, its dipole moment will not become 0 because it is not non-polar now, it is a polar. So as it is a polar molecule now here, its dipole moment value will not become equal to 0. So hence we can select the option B also the correct answer. And coming to the option C here. In option C here, if you observe, it's a benzene. Benzene, you very well know that it is a non-polar compound. So as it is a non-polar compound, its dipole moment definitely will become equal to 0. So this we cannot select here. And similarly, if you take the fourth option, and the fourth option is here naphthalene. Naphthalene is also here a non-polar compound. As it is a non-polar compound, this also we cannot select here because its dipole moment value will also be 0. Hence, what are the compounds for which dipole moment value is not equal to 0 means the first compound, that is option A, and the second compound, that is option B. So these two are the compounds in which dipole moment value is not 0. So hence the answer for this question is option A and option B. Now let us take the next question, that is question number 2. Second question is like this. So which of the following have a larger CO bond length than CO bond length in CH3 C double bond O CH3, that is acetone. So CH3 C double bond O CH3, acetone. So in acetone compound, so we are having a C double bond O group here. So in that C double bond O group, it will have the bond length here. So this double bond length it will have here. And in which of the following compound the CO bond length is larger than this C double bond O group compound? It is asked here the question. So let us find out in which of these compounds the CO bond length will be larger than this CO bond length. Now if you observe the first compound is given a 7-membered ring, and second compound is given a 5-membered ring, and a 6-membered ring, and a 6-membered ring here. Now in these compounds, if you observe the first compound, if you observe here, so here also it is having C double bond O group, so here also it is a C double bond O group, here also C double bond O group, and in this compound also C double bond O group. Now in this case, if you observe here the first compound, this compound is not having any aromatic nature. So to get the aromatic nature, the molecule will be polarized in this way. So oxygen being more electronegative, the oxygen will pull away the bonded pair of electrons towards itself. As a result, oxygen will get negative charge and carbon will be getting the positive charge. So as a result, we can observe here, so oxygen will be getting negative charge, carbon will be getting positive charge. And the double bonds position will be as it is like that. So because of this polarization, this molecule is getting aromatic nature. So the molecule is getting here aromatic nature. So because of that aromatic nature, it is losing its C double bond O group and it is converted into CO single bonded group here. So as a result, this bond length will be larger than this bond length. So first option we can select where the CO bond length is larger than C double bond O bond length. Now go into the second option. So in the second option, if the same polarization, if you observe here, it will loses its aromatic nature and it will become here anti-aromatic. So instead of showing that one here, it will not show any polarization. So hence we cannot see any polarization in the second compound. And if you observe in the third compound, because if it is undergoing polarization, so what happens is here it will become negative, this will become positive. As a result, it will get here anti-aromatic nature, which the molecule will not prefer, because anti-aromatic compound will be unstable. So that's why it will not prefer here to show this anti-aromatic nature here. It will not prefer this polarization here. So hence the molecule will be present as it is like that only. And if you take the third option here, in the third option here, C double bond O group is in conjugation with the double bond. So C double bond C is in conjugation with C double bond O group here. As a reason, because of this, we can see a resonance here. So that resonance leads to negative charge on oxygen and a positive charge on carbon. So as a result, this compound will convert into a 6-membered ring with a double bond position here, and this carbon will be getting here now single bond. The carbon oxygen bond will become now a single bond. As a result, the bond length will be increased, and so we can take the third option also as an option in which CO bond length will be more. Now if you observe the fourth option here, in this option there is no chance of any resonance, because there is no any conjugation system and there is no factors polarizing the compound here, because it will not acquire any aromatic nature. Hence this compound will remain as it is. So option B remain as it is and option D remain as it is, because in option D, if it is showing polarization, it will convert into least stable anti-aromatic compound. So that's why it will prevent the polarization here. So only the compound A and compound C will show polarization. As a result, CO bond length increases. So we can select option A and option C as the correct answers. Hence the correct answer for this question is option A and option C.